Welcome to RStudio and our Part 3, Data Manipulation. This is Dr. N. Mao, Professor of Information Systems. In this tutorial, we will go over some very important and useful functions that will help us to clean up data and do some simple manipulations very efficiently. Some of the things we'll be doing are learning how to rename columns, recode data, and using the pipe operator, learning how to count, sort, filter, and extracting unique values, and so on. Let's get started. The first step, we will install and load those packages we have done previously, so I will not go over this in detail. I have already pre-installed and loaded these libraries, tidyr, dplyr, and tidyverse. Next, we're going to import data from Excel this time. And to do that, we will first go into our environment right here and find import data set from Excel, browse to where the location is, after you load it, you will notice that there are different tabs, different sheets allow you to pull up. In this particular data set, I have two different sheets. One is sample survey, sensor, and coding. So I actually can switch right here. You can see the different tabs or sheets in my Excel file. The name is where you actually specify how you want the name of the file to be, and I will keep the same file name for now. And I am importing the sample survey data first. And here's the code you can see. And now I'm ready to import. You can see the data frame is already loaded up for me, which is CIS sample. Next step, we'll go and select and rename some columns. We have done this previously, so the code for selecting columns by index is data frame name followed by the square bracket. C stands for the columns, and those are the index numbers. I'm selecting the first, third, and fourth columns. Once we have selected the columns, we'll rename them into the three different column names here: appointment ID, survey, and response, all in lower cases. Just to remind you, if you want to rename just one column, all you have to do is names by the data frame name, specify which column it is, and the new name. So the first thing we're going to do is pull out our sample, CIS sample, the data frame, and square bracket C, and we're going to select, if you look at our data, again, appointment ID column, the first column, third column is the questions, and the fourth column are the responses. Immediately you will see the data is being selected, those columns: appointment ID, question text, response. Let's go ahead and put this into a new data frame. So we'll call this CIS sample 1, and we're going to repeat that. CIS sample and square bracket C 1 3 4, and run that. You can see we have a resulting CIS sample 1 with only 3 variables. If I click on it, you will see this reflected up here. Next, I'm going to rename my column headings using the names function. And it's going to be CIS sample 1. And it's going to be the column headings. I'm going to put in double quotation marks. And it's going to be apt ID, all lower cases, separate by comma. The next one will be survey, comma, and response. So as soon as I press enter, you can see the new names reflected. Next, we're going to recode our response data. And to do that, we define the data frame name, use the $ signifying is a column, the column name, and using the recode function, and repeat data frame and the column name. What is the old value in double quotation marks equals to what's the new value, double quotation mark. For example, if we're going to change the response column for our CIS data sample, I'm going to recode it, that same exact column, and the old value is yes, definitely, and we're recoding that into the number 3. And go over all the different variations. You just separate all the variations by commas. Then you have yes, somewhat, which is 2, and no is 1, yes is 2, and so on. Okay, so let's go ahead, take a look at how we can do that. So again, we're recoding this column, response column, and we want to make sure all these text responses are converted to numbers so we can use them in data analysis. Typically, the good practice is to use a template so you don't actually type in, introducing a lot of errors. So I'm actually going to import the coding subsheet in my Excel file I showed you earlier. So let's go ahead and import that from Excel. I'm actually going to import the same file, but I'm selecting the coding sheet that I have already developed in Excel. So for this one, I'm going to call it coding. I don't want to overwrite my data frame, keeping lowercase. All right. So to make it easier, I'm actually going to use this text as I type in my names. So let's go ahead and do the CIS sample 1, and I'm changing the column, which is the response column. Okay, and it's going to be coming from the function recode, and repeating my CIS sample 1, this column response, and I see I have a misspelling here, response, and now I can start typing in the old value. I'm actually going to copy this, copy, and come here, Control V, so I don't risk any mistakes. And this is going to be 3, comma, and I'm going to go Shift Enter so you can see a little bit better. And the next value will be Control C to copy, and I'm going to come here, Control V, make sure delete all the space, and this will be 2, comma, the next one will be no. So this actually I can do it. So let's go no, which is gonna be the value of 1. And yes, which is 2. And let me Shift Enter again to go to the next line. And I have 10 best. Quotation marks and equals 10, separate by comma, and I'm going to do my 0 worst, Control C, Control V, and this is gonna be 0. And I'm gonna scroll down to see whether there's anything additional to recode. I'm leaving the non-responses as it is. So let's go ahead, just run this. And if we go back to our sample 1, you can see all the responses have been recoded, right? Pretty nice. What is even more impressive is this can be done to a larger data set. So let's say you're practicing recoding, cleaning a smaller data set, and once you know the method that's correct, putting this into a script, and then you can run it on a larger data set. So at this point, we can actually attempt to go spread this particular data set. To spread the data, there are 3 compartments after you defined your data. So the keyword is spread, data frame, and what's the key? Key will be, in our case, will be the survey, which will be spread into separate columns. So each survey question will be its own column, and the responses will go into the value. Let's type that in. And CI is data sample 1. The key in this case is survey, separate comma. The value is response. Okay, and enter. Whoa, what is going on here? So here we can see there is an error message. So we scroll up and see this error says each row of output must be identified by a unique combination of keys. Keys are shared for 44 rows. So they show you that there are some duplications here. Because of duplication, without a unique key, you cannot spread, which is a good thing actually in R to prevent you from doing that. So that means we need to go figure out what are the duplications. So let's take a look at how we can identify some of the duplication problem. We're going to learn this really useful pipe operator, which is signified by percentage sign, greater sign, and percentage sign again. So to get that easily typed in, you can use the keyboard combination Control-Shift-M. So the pipe operator, the whole idea behind this is to make the syntax really easy to understand. So it saves a lot of steps in between. So make the code much easier to understand. This particular line we're trying to do is to identify the number of distinct records for each of the column. So here we define what a data frame is. Use the pipe operator to say, tell me about this particular data frame. Using this, map it out to see how many distinct records there is for each variable. So for our data frame, we have 3 columns, 3 variables. So it's going to produce 3 separate numbers to tell us how many unique numbers we have. So our data frame here is data sample 1. And again, Control-Shift-M will bring up the pipe operator, make it easier. And we're going to use the map double to count the number of distinct and underscore distinct. Here is showing us we have 6 unique appointment IDs, 12 survey questions, which we know from the survey rack card we were given. There are 12 questions. I had mentioned in class there are actually 2 questions added in 2018. So in our data set, some of the questions are in 2017 with 10 questions, some are in 2018 with 12 questions. So if we look at here, 6 times 12, that doesn't really match to 86. 86, it was only 72. So there's something going on. We have some duplication data. Now we know there's some duplication. We can also go further to see which ones actually were duplicated. So we can do that by counting the records by appointment ID. So we're going to do a function using count and counting the sample by appointment ID. So let's count. So we're going to do the count function and CIS sample 1. We are counting by appointment ID, and let's see what it looks like. Now you can actually tell there are two records, 2295575 and 4327543. Each of these are counted, the count exceeded 12. That means there are duplications. So this you can tell is in 2017 because it doubled by 10, and this one is in 2018. So let's go back to the data set so we can take a look at the, what was the duplication look like. We can actually go back to the original data set. We can search. Let's copy this. Control C. I'm actually going to use the search box here. Control V. And make sure there's no space. And you can see all these data records are shown. I can actually also sort using the viewfinder here. So let me sort by the question text first, and then sort by question appointment ID. So these are the 229575, and you can see there are 20 of them. Okay, and each question is completely duplicated. So if we look at the other one, it's most likely the same situation. And let me sort by question text and appointment ID. Yep, it's the same exact situation here. So now we can confidently say that we identified these two records, and we can actually save this into a data frame. So let's go ahead and call that appointment ID count and put this count into it. Actually, let me just reuse the code here and put my data frame back in. Okay, so now I have my app ID count. I can also sort using the arrange function. So let me just break it down for you. To sort, we can use arrange function, and let's do that. Okay, so we can arrange, and which will do the same thing as we did earlier. Okay, so I just want to show you different ways. So we're going to arrange. Let me go back. Appointment ID, app ID count, and we're going to sort that by the number, the n. Okay, so this will make it a little bit easier. We can also put this into a data frame. What I want to do is actually put this into a data frame to make it filter it. So I'll only keep the ones with the exceeding 12. So those are the duplicated records. So I just want to save these two. So I'm going to actually filter it. So let me go back to show you the code. So I can filter data by specifying the criteria. In this case, will be greater than 12. Okay, so I use the filter. Filter out my appointment ID count, right? And this will be n greater than 12. Okay, so now I only have these two records, and we'll save this into So let me go and save this into a data frame called this duplicated. So that way it becomes easy for me to go back and track. So now I have a duplicated data frame, which tells me which records or appointments were duplicated. Now we can confidently say that we have identified a duplication record problem. So we can actually extract unique records at this point. To extract unique records in R, it's very simple. We use the keyword unique function and followed by the name of the data frame. So let's do that. So we're going to put this data frame into our CIS data sample 2. Okay, and using unique, and it's going to be our data sample 1. And let's look at our 2. Before I even open it up, you can see I have eliminated, right, 24 duplicate records. So now we are left with only the unique records. At this point, we can spread again. So this time we're going to be spreading CIS sample 2, and the key will be survey and separate comma value response. Okay, beautiful. You can see everything is spreaded into the appropriate columns. We have appointment ID, the first column, enough time, explain, listen, and etc. Okay, so at this point, I can confidently put that into my data frame. I'm going to call this survey data because it is in a good shape to be our survey data. Okay, so survey data now have 6 observations, and we can see everything is beautifully laid out. I don't want my open-ended question to be in there. So if you remember, we did that previously. So we can actually subtract a particular data column out by using select. And we're going to be selecting from the survey data. And we're going to say minus. Again, that is open-ended. Okay, so we can take out that column. Like magic, is gone from our data frame. Last step we're going to do is to merge our data. So we already spread successfully, and now we're going to merge data frames. So this can be done very easily in R again, and it's done with really high speed, much easier than using VLOOKUP to match 2 data frames, 2 data sets. Here, let me explain how to do it. If you have matching names in terms of column headings for 2 data frames, it's as simple as just saying merge first data frame, second data frame, separated by comma. If there is a name mismatch, you can also use the third example here. You can merge, specify the X is the first data frame, Y is the second data frame, and which ID you're going to be using for X. So specify the ID name, and by Y, the column heading. And there are 2 different possibilities for you to match. One is all equal to false, which is a default. When you don't specify it, it's by all equal to false, which means only the records are matched between the 2 data frames are presented. If you include all equal to true, that means you will include all the records from both sides, both data frames. So if a data frame does not have certain type of data, you will just leave them as not available. So let's take a look at an example. So now I'm actually going to import my other data frame to match into my survey data we have with the CIS data, we have the wait time data. We can actually merge these two data sets together. So let me import my data set. I'm actually going to import it directly from my original CIS data. The only thing I did was renamed it CIS1 to make it a little bit shorter. And make sure you go to the wait time data. Actually going to change this to wait time, and instantaneously everything loaded. And that's the beauty of R. It's highly efficient, and there's really not much delay like we see in Excel. So let me make sure, enter my wait time, so it changes to wait time, and import. You can see the 42,936 rows of data with 17 different variables loaded instantaneously. Before I merge the two sets of data, I want to make sure I have the matching column IDs. So appointment ID, I want to change that to app ID like I have in my survey data. So to do that, remember use names function, and this is my wait time data, and I want to change my first. So you can see this is my, oops, let me go back. I need this square bracket. I want the first column to be changed, and the name will be, in this case, app ID. So this will match with my, again, my survey data, okay, app ID between the two data frames. Now I'm ready to merge. So the merge is extremely easy. So wait time and survey data. Okay, that's all we're doing. And I can see it succeeded with the 6 rows. In this case, I use the default, not adding any all equal to true, so it's all equal to false. Only the matching records are presented, because you know that we have 42,000 rows in my wait time data and only 6 rows in survey data. So if I put this into a data frame, I'm going to call merge 1. You can see merge 1 has 6 observations and has all 28 variables in here. Okay, pretty cool, right? So 28 because you have 29 total variables, but there's one overlapping, which is app ID. So 29 minus 1 is 28 total variables in merge 1. Now let's see how we can merge to have all the rows from both data frames. Remember, the default is all equal to false. So if we want to have all the rows, so we're going to call that merge 2, and we're going to say all equals to true. Oops. And that means all the rows will show up. So as soon as you press it, you can see merge 2 has all the rows, 42,936. So let's go ahead and take a look at merge 2 and 42,000 rows. And if you scroll to the right to see the survey data, a lot of them will be in A, means not available. How cool is that, right? Very, very efficient. It took almost no time for everything to merge. And the best thing is everything is reusable. To finish this assignment, I want to create a script. And for this time, I want you to make sure you include the headings for each step. You can use the instruction sheet that's included and putting information, for example, the file name, RStudio R Part 3, data manipulation and cleaning. Your name must be there. And then you can start inserting number 2 and the relevant code, number 3, and so on. So organized from 1 through 12. So there you have it. Thank you for learning with me again, and I hope you are falling in love with R more and more. It's such a beautiful language, and I hope you can see from this particular exercise, things are very efficient. You can do things much faster than you can in Excel, and actually it's also much more secure. If you have any questions, please let me know. Thank you for watching.